In Chapter 3, we will learn about selection statements. In Chapter 2, we wrote a program to compute the area and perimeter of a circle with radius 5.5. We improved this program by allowing the user to enter a value for the radius. Now we want to consider the case when the user may, either accidentally or on purpose, enter a negative value for the radius. Of course, this is an invalid input, so we don't want to continue with the computation. Instead, we may prefer to inform the user that their input was invalid and end the program. Until now, we have no way to do this. In this chapter, we will introduce the solution, the selection statement. So far, we've introduced numeric data types and have said that we will use the type int for integers and double for floating point or decimal numbers. We are now introduced to another data type, the Boolean data type. The Boolean values are true or false, so a variable or constant of the Boolean data type can be either true or false. We use the same syntax to declare a Boolean variable or constant as we did to declare an int or double variables or constants. A Boolean expression is an expression that evaluates to a Boolean value. Selection statements use conditions called Boolean expressions to determine which statement or block of statements to execute next. One example of this is the necessity to compare two numbers. If we want to compare two numbers, say radius and 0, we will use a comparison operator, also called a relational operator, to make the comparison. The result of the comparison will either be true or false, a Boolean value. Java offers 6 relational operators to compare two operands. The result of these relational operators is a Boolean value. For less than, we use the standard mathematical symbol for less than. For less than or equal to, we use the less than sign immediately followed by the equal sign with no space. For greater than, we use the same mathematical symbol for greater than, and for greater than equal to, again, the greater than sign followed by an equal sign with no space. If we want to compare if two operands are equal or equivalent to each other, we use the double equal sign. This is very different from our assignment operator, the single equal sign. If we want to compare if two operands are not equal to each other, we use an exclamation point immediately followed by an equal sign, again with no space. Now let's consider an example. Listing 3.1 introduces a program that creates a simple addition quiz. Please review the code in Listing 3.1 in your textbook and watch the video note for detailed step-by-step development of the program. As you do, it is important to note the following concepts. Because the program will require user input, we must use our scanner. Pay close attention to identify the statements required to use the scanner. We will use system.currentTimeMillis to generate a quasi-random number. And later we're going to discover another way to generate random numbers. Additionally, the concepts of casting as well as the division and remainder operators are used. Notice the use of the relational operator equals the double equal sign, which is used to compare the user's answer with the correct answer. Again, please refer to the video note in your textbook for an in-depth explanation of Listing 3.1. A selection statement is a construct that allows a program to specify alternative path of execution. Essentially, a selection statement allows us to skip over a block or blocks of code based on some condition. One example of a selection statement is an if statement. This slide demonstrates the one-way if statement. The syntax of the if statement appears on the left of the slide. An if statement begins with the keyword if, followed by a pair of parentheses, which contains a Boolean expression. That's followed by a pair of curly braces, and inside those curly braces are one or more statements. The statements that appear inside the curly braces will only be executed if the Boolean condition inside the parentheses evaluates to true. If the Boolean condition evaluates to false, the computer will skip over the block of code enclosed in the curly braces. We use a flowchart to pictorially describe an algorithm or a process. A flowchart uses various shapes connected with arrows to demonstrate the flow of control of our program. In our flowcharts, we'll use rectangles to designate statements and diamonds to designate Boolean conditions. Diamonds designate decisions. The diamonds will have two arrows or branches, one representing true and the other representing false, because these are the only two possible outcomes when a Boolean condition is evaluated. When the Boolean condition in the diamond evaluates to true, the arrow labeled as true is followed, and the statements that appear in the rectangle at the end of the true branch are executed. When the Boolean condition in the diamond evaluates to false, the arrow labeled as false is followed, and the statements in the rectangle are skipped. The flow of control of the program will continue with the statement following the closing curly braces. Consider our previous program that allowed the user to input the radius of a circle and reported the area of the circle. Until now, if the user entered a negative number, the calculation continued, although the reported answer made no sense. The user had entered a bogus input. Using the if statement, we can now only perform the calculation when the user enters 0 or greater for the radius. We use the Boolean expression, radius greater than 0, to determine when that calculation is performed. On the right side of the slide, you'll see the corresponding if statement. If radius is greater than or equal to 0, we're going to perform the statements that appear in between those curly braces in that block of code. It's worthwhile to note if the radius is less than 0, the computer simply skips over those block of statements in between those curly braces. Consider the if statements on this slide. In the top pair of if statements, the statement labeled A is incorrect and produces a syntax error. The parentheses surrounding the Boolean expression are required. And although it's not demonstrated here, it's also worthwhile to note that it's necessary to have a space between the word if and the opening parenthesis. As a matter of completeness, the second set of if statements demonstrates the equivalence when there's only one statement in the curly braces. In our class, we're always going to use the curly braces, even if we only have one statement. Also, we will always use the end-of-line style for our curly braces, as we discussed in a previous lecture, and you will be required to comment the closing curly brace, even though the book doesn't always do this. In listing 3.2, the user is asked to enter an integer. The program determines if the number entered is a multiple of 5, and if it is, the program displays high 5. Next, the program determines if the number is a multiple of 2, and if it is, it displays high even. You will want to pay particular attention to the use of the remainder operator to determine multiples. Suppose we have a number called num1, and we want to determine if num1 is a multiple of another number, say num2. Well, if num1 is a multiple of num2, then whenever we divide num1 by num2, we get a remainder of 0. And so we use this fact in our program to determine if the number entered by the user is a multiple of 5. We do this by evaluating the Boolean expression shown on line 9. If num mod 5 is equal to 0, then we perform the print statement on line 10. Likewise, we can determine if a number is even, that is, if a number is multiple of 2, by evaluating the Boolean expression on line 13. If a number is a multiple of 2, we evaluate the expression number mod 2 is equivalent to 0. You want to pay very careful attention to the use of the Boolean or relational operator equals equals, that is, 2 equal signs with no spaces in between, to determine or denote equivalence. We do not use the assignment operator, that single equal sign here. That would produce an error. With an if statement, we're able to perform a block of statements only when the Boolean condition is true, but often we wish to execute a completely different block of statements when the condition is false. To accomplish this, we need to use an if-else statement, or a two-way if statement. An if-else statement decides the execution path based on whether the condition is true or false. That is to say, if the condition is true, it executes a designated block of statements, but if the condition is false, it executes a completely different block of statements. This is depicted in the flowchart on the slide. You will notice that after the appropriate block of statements is executed, the flow of control returns to the statement immediately following the if-else statement. The syntax for the if-else statement is also shown on this slide. Take a moment to review the code on this slide. We can now use the if-else statement to improve upon our program that computes the area of a circle by sending the user an error message if they enter a number that's less than 0. The code that computes the area and reports back to the user will only be executed when the user enters a value of 0 or greater, and the code that reports an error message to the user will only be executed when the user enters a value less than 0.